Welcome to Chapter 14, Environment and Resources. In some ways, this probably should have been the first chapter of the entire book because everything we've talked about is connected to the earth, to natural resources, to nature, and to the environment. So before we get into some of the specifics and definitions, and we're going to talk about coal and natural gas and oil, I'd like to start with some imagery of the earth, of specific places on the earth that have specific meanings to me as a professor and as a person, and that have deep meanings to the people that live there. So by some accounts, this is the oldest tree on earth, the tree you're seeing to your right, which is located in a mysterious location in eastern California. The location is not divulged by those that manage this resource because they're fearful of what might happen. But this tree is nearly 5,000 years old. Very often, we as humans think of the earth in terms of our own lifespans, which is usually less than 100 years old. And so we think in terms of those scales. And maybe we think one generation before us and a generation or two after us. But most of us tend to think within the scope of our own lifetime. The image from the left, and these are mostly images that I've taken myself, are of a sacred volcano in the high plains of central Mexico, known as Popo for short. And this is a volcano that kind of looks over the entire landscape of Puebla and surrounding communities. This is just south of Mexico City. This volcano had deep meaning to the Aztecs and even people that lived prior to the Aztec civilization. There are stories about how this volcano came about because of a long-lost love of a soldier that couldn't be with the woman that he loved because he was sent to war. And so he was turned forever into this volcano. And that when Popo erupts, that it's connected to that expression of love and of frustration. For some people, the beauty of nature might look like this. This is also a photo that I took, and you might be able to identify this from the landscape, that this is in eastern Canada. You could certainly tell that this is in a northern climate, that this isn't a tropical beach that you think of maybe that where tourists would visit. But this image of nature is full of all sorts of meanings. For example, the Atlantic Ocean here provided sustenance and fishing, and still does, for millions of people that rely on fish, specifically cod, for their livelihood. But the cod dried up. The cod were overfished by around 1991 or 1992. And so the cod fisherman was ended. There was a moratorium placed on fishing cod. It's also the location where the first transatlantic cable was laid between connecting Europe and North America. So the very first telegraph and then later phone call could be placed so that people could speak directly between the old world and quote unquote the new world. This also happens to be just a few hundred feet from the place where I got married. So it's moving to the northwest deserts of of Argentina. You find this huge amounts of salt, which have been an incredibly important resource for obvious reasons. Salt is required for human life, for all animal life, as a matter of fact. And this has been a major source of salt in Argentina and much of South America for thousands of years. Prior to the existence and the encounter of Europeans, this has been known. And indigenous communities live here, and they maintain control of the land, but that control and that access is being threatened by the discovery of large amounts of lithium right here, which would destroy indigenous rights and access to the salt as lithium becomes more valuable. And so this sign in the background is stating no to the megamines of lithium, which would threaten their livelihood. So this conflict between nature and between resources and between various human interests, between the global and the local, is happening on multiple corners of the planet. I'll quickly take you next to an island in the Philippines in the South China Sea, one of the most valuable and beautiful tourist destinations in all of the Philippines and all of Southeast Asia, as a matter of fact, is a place where, again, fishing had been the livelihood for who knows how long, thousands, tens of thousands of years to human beings. But as more and more tourists showed up, then the livelihoods changed. People still fish here, but the more valuable resource is the beauty of the sea. And you can probably make it out on the ship that this boat is being used for diving, for scuba diving. And so tourism has taken over fishing. But along with that, tourism has emerged over-tourism. And the over-tourism and the excretions into the sea of all sorts of things, including sewage, has increasingly led to the emergence of things like this, algae and other contaminants, as a result of the overpopulation of the island. That's a place where I spent a lot of time once upon a time. Moving back to the high desert now on the other side of the Andes Mountains, this is the Atacama Desert in northern Chile. And something similar is happening because the lithium that's threatening the salt mines is also threatening the ecosystem of these pink flamingos. And they've been declining in number substantially as mining has increased just on the other side of this mountain, because it's reduced the amount of water that's being released from the Andes Mountains that feed this lake, that provide food for the pink flamingos. The next one is in Santiago, Chile, and I just love this image because of the impact of the Andes Mountains and the water that's provided from the Andes Mountains that sustains a massive city like Santiago, Chile. And it's become, although it's one of the most isolated cities in the world, it's also the wealthiest city in Latin America. And then finally, to the southwestern coast of Mexico in the state of Oaxaca, there's a little village called Puerto Escondido, which again has been a sleepy fishing village for a long time. But in the last 40 to 50 years, surfers have made their way to this town for obvious reasons, because these waves are massive, they're enormous. And so I took this photo, and on the very next day I learned that a surfer had died the same day that I was taking this photo. I didn't see the surfer, never encountered him, but he was actually a professional surfer, somebody that was very good at his craft. And yet nature was stronger than he was on that day. So I just wanted to use these photos to kind of open the discussion of environment and resources before we jump all the way into coal and gas and all that kind of stuff. Just to drive home the point that as detached as many of our lives seem to be from nature, that this battle and this situation continues, in which we have to live in concert with nature, even if we don't see it. When's the last time that you touched nature? Have you been hiking in the woods? Was it watering your lawn? If you live in the suburbs, then your lawn is probably not natural. It's probably a grass that's at a foreign species to what would have been there before you lived in that neighborhood. Okay, so let's hit some of the basics here. And one last thing that I'd like to do is that if you're a GGC student, I'd like to introduce you to the fact that we do have a major. If any of the topics that I've talked about with the photos that I showed you are of interest to you, and you're interested in environmental issues, either personally or professionally, I would invite you to take one of our 2 physical geography classes that are offered as a part of a science lab, and also to consider taking courses in our environmental studies program. We have an environmental studies major in a variety of concentrations, and I've given you a QR code here that you can use to learn more about that. Moving beyond that, here's what our outline looks like. It's a very short outline, and so let's get to it. Let's start with energy consumption, energy use. One of the things that we can probably tell almost instantly from this map is that the countries with the highest energy use per capita mirrors very carefully a map that I've showed you before, a map between the global north and the global south. And so energy consumption obviously increases with wealth. But it's not quite as simple as that. When we break this down in a per country basis, and again, these are per capita uses of energy, The amount of energy that each individual consumes is not necessarily a direct result of what they consume, but what the entire country does for a livelihood. So countries that tend to be more industrial, countries that tend to be more focused on the petrochemical industry, for example, like in the Middle East, in places like Qatar, Saudi Arabia, are going to have higher energy consumption because of how much energy it takes simply to drill and produce and transport and process that energy. So the countries of Bahrain, of the UAE, Brunei, Kuwait, etc., all have really high per capita consumption rates. It doesn't mean that they're eating more food or that they're driving their cars more necessarily. It simply means that there's more industry in those places. And of course, people in the poorest countries of the world simply consume less energy on a daily basis and have less manufacturing, less industry inside of their borders. So that's reflected here on this map. But there's a couple of things I like to point out. And so first of all, the high energy use is explained by wealth and high GDP. So aside from industry, wealthier people have more money to spend, and so they consume more energy. That means they buy more stuff. They go on road trips. They go on vacations, right? So they do consume more energy in their daily lives. They probably live in larger houses. They have heating and air conditioning, which leads me to the climate region. So countries that are in the north, further north, with really cold temperatures, tend to consume more energy. So Canada has a higher energy consumption than the United States, for example. But again, it also relates to the petrochemical industry. What else do we have here? It also relates to the housing, heating type and density. So you can't see it clearly on this map, but the difference in energy consumption between Norway, which is right here, and Sweden, which sits right next to it, almost the exact same geography, is very different. So Norway has a really high energy consumption and Sweden has a much lower one. And part of the explanation for that is housing type. So Swedish houses tend to be more densely populated with people sharing a wall. They also have access to a shared heating system rather than each house having its own heating oil or heating source, which leads to greater efficiencies. So there are all kinds of reasons for this. And then we've got Iceland over here, a country that I almost never talk about in class, a really low populated country here in the North Atlantic. But the thing about Iceland you'll notice is that its per capita energy consumption is incredibly high, one of the highest in the world. And what's the reason for that? It's a really simple reason, that Iceland is one of the world's largest producers of aluminum. And which takes huge amounts of electricity, and that electricity and that energy, in the case of Iceland, is powered by geothermal energy. The same reasons that Iceland has a lot of tectonic activity and volcanic activity is that Iceland has also learned to capture that energy that's happening just below the surface of the country. They've tapped it, they've trapped it, and they've converted it to usable energy, which makes the electricity in Iceland very cheap, which positions it to become one of the world's leading producers of aluminum, which is a high energy process. So let's look at the United States specifically across time and electricity generation and power generation. If you look back to the late 19th century and into the beginning of the earliest century, almost all of our new power generation was of a single type, hydroelectric power. This means that we were building massive numbers of dams in the West, in the East, eventually in the southern states as well. And so it's really in the early 20th century that we begin to explore and exploit more and more other sources of energy for our electrical needs. And of course, prior to this, right, in the 1800s, most people were living on farms. Energy was being produced locally by burning wood or by burning kerosene or something like that. But most homes were not wired for electricity. Most people, well, nobody was driving a car. We were using trains for long distance travel, and those trains were powered by what? They were powered by water, and then later powered more and more by coal. So you can see the emergence in the early and mid 20th century of coal. This is when coal becomes king. And then at the same time, we're discovering more and more natural gas and oil in places like the Gulf of Mexico. And then we play around with nuclear. We realize that certain sources of energy were not going to last us long enough, and our appetite for energy was increasing dramatically as we were increasing our levels of manufacturing in the 1960s and 1970s. And so we established new nuclear plants, which provides huge amounts of energy, but there were concerns about the long-term impacts of nuclear energy on the planet, on the environment, on humanity, the possibility of a catastrophe and what that would mean for human life. And so we backed off of nuclear power, and we moved towards new renewable energy sources, things like wind and solar here, just in the latter part of the 2000s, right, in the 21st century. So the lesson here is that we've transitioned, we've changed from one energy source to another. That doesn't mean that the old ones went away. It just means that we're constantly in search of new types of energy to use for our society. Keeping on the theme of hydroelectric power, I think it's interesting to see just how many electric generating dams that we've built across the United States, but most of these are very old. They were done as I showed you on the graph before, in the early 20th century, and then into the 30s, 40s, 50s, in the post-Depression era. A lot of these dams were built after the Depression to give people jobs, to promote electricity, and to provide jobs for the masses of people that had lost their jobs during the Great Depression. So we have massive damming that's happened in the South, and that damming happened later, not in the early 20th century, but more like in the mid part of the 20th century. And that electricity has generated all sorts of cheap electricity, which has also been the engine of growth for manufacturing in the South. So in the previous chapter, I talked about Auto Alley and how new automobile plants oftentimes are located in the South. Many times those automobile plants or fabrication plants and industry of all sorts are taking advantage of this cheap source of electricity that comes from hydroelectric power. Not all of them are, but some of them are. The same thing for early automobile manufacturing in the northern states along the Great Lakes. So they were using coal and they were using natural gas, but they were also using hydroelectric power. And look at the Northeast, right? Huge amounts of electrical power generated from the Northeast. Okay, so the lesson here is that we've sort of dammed as much as we can dam in this country. There aren't new sources of hydroelectric power that we can tap into in the U.S., but there are other sources of renewable energy that we'll talk about in a minute. So as of the latest data in 2024, about 9% of energy consumption in the United States came from renewable sources: wind, solar, geothermal, and that's about it. So we're still heavily reliant upon fossil fuels for our daily energy needs and for our industrial output. This map sort of shows the same thing, but we can also see the rise of natural gas and the decline of coal more clearly in this second graph. So perhaps surprising to many people is the fact that actual per capita energy consumption, which had risen precipitously through most of the 20th century, kind of hit its peak in the 1970s, and then we hit another peak in 2000. But from 2000 onward, we've seen a decline in the amount of energy that each consumer or that each individual uses in the United States. And again, that might be a surprise since we have more electricity, we use more gadgets, we have larger homes, like I said. We use more refrigeration for all sorts of things. We use more gadgets and more computing than ever before. So what's the explanation for that? And maybe you can think about this and come up with your own answers, but it's pretty basic. Why has this happened? Mostly increased efficiency in vehicles, in heating and cooling, in the cooling systems and heaters, and moving away from coal, which isn't that efficient, to more efficient systems of energy. Also, climate change. So we've had cooler winters, which has resulted in needing less energy to heat our homes for those of us that live in places where we need to heat our homes. And then we've had smarter and smaller devices. Just one simple example of that is this smart thermostat. You probably have something like this in your home. I think this one's a Nest thermostat, and so it can mediate. It doesn't waste energy nearly as much as the old systems did. So will that continue as we move forward into the 21st century? I don't know. We shall see. Maybe we'll keep getting more and more efficient even as we have more and more. As I mentioned previously, this could have easily been chapter 1 of the textbook because the Earth and its resources and the environment serve as the basis for almost every other subtopic that we've discussed throughout the semester. We really can't have large human populations without good resources, right? So we don't have large population clusters in deserts or in rainforests. We have them in areas with good farmland. Migration. People have very often migrated in search of new resources and new access. People migrated away from Ireland when there was a food shortage. And where did they wind up? Many of the Irish wind up in the United States, where there's new land and new access to farming possibilities. Economics are very much mediated by access to especially fossil fuels in the 20th century. Maybe in the 21st century, it's renewable energy. We shall see. Culture takes its cues from the natural world around it. The stories and the myths and beliefs oftentimes are very much connected to the natural world, even if we don't even live in the natural world anymore, even when we live in the city or in the suburbs. But in the end, I've used this quote I think once before, but Mother Nature always bats last and always bats 1,000. So humanity is in this constant struggle to fit in with the natural resources that are around it. Humanity is beginning to shrink in population, as we've talked about many times before. And maybe that's a result. Maybe that is a subconscious or a conscious reaction to the strain that the planet finds itself under. I don't know the answer to that. That's something for you to think about. But what we do know is that our relationship with natural resources change across time, and I talked about that a few slides ago. But our consumption of coal has been in sharp decline since the early 2000s. We came to a realization that coal created all sorts of air pollution, dangerous working conditions, and had all kinds of negative effects. Even though coal was the main driver of manufacturing in this country for a long time, it provided lots of well-paying jobs for people in places like West Virginia. We've moved to a different understanding of our relationship with that natural resource. Meanwhile, in China, coal consumption is through the roof. So most manufacturing in China is being driven and being powered by large amounts of coal. Air pollution is at an all-time high in China. Respiratory diseases are at an all-time high in China. So even as China has accumulated massive amounts of wealth and achieved high levels of economic development, the health of its people are under threat because of this coal. So we can see that two countries are in very different places in terms of this resource. And it doesn't seem to be slowing down. So just in 2024 alone, you can see the establishment of new coal-powered plants that have been established in China. And notice the geographic pattern here, very much along the coast, as we've talked about before, and along rivers. So this is absolutely connected to manufacturing, to distribution, to transportation systems. And so now China is responsible for about 20% of all global CO2 emissions, which we'll talk about in a second. And then India is second with about 11% of all CO2 emissions on the planet. But both of those countries are following the same trajectory that had been set forth before, first in England and in other parts of Europe and then in North America, in terms of moving from a low-income society to higher income, manufactured and industrial, and eventually post-industrial society. So non-renewable resources are those with a finite supply. Duh, you learned that when you were in 5th grade. And most non-renewables, nearly all that we're talking about, are fossil fuels, derived from ancient plant and animal matter millions of years ago. Most oil did not come from decomposing dinosaurs, as you may have learned from a myth that's sort of been propagated over and over again, but rather across millions of years of time, it's plant and small animal life that faced severe compression and eventually decomposes and results in fossil fuels, natural gas, oil, and then in some cases coal. So proven reserves are the amounts of, or the deposits that can be recovered with some degree of certainty, that we have geological science, then we have drilling, and then we have evidence, and we pretty much have a good idea about how much oil exists in a particular place. The largest coal reserves around the world are in the United States, Russia, Australia, and China. And kind of the random availability of those coal sources led to industrial revolutions in each of those places. But again, Australia is consuming less coal, the United States is consuming less coal. Meanwhile, China is increasing its consumption and production of coal. There's a slight discrepancy in the textbook compared to with what international data tell us in the first quarter of the 21st century, and that is that Venezuela has the largest proven reserve of oil of any country on the planet. And then that's followed by a variety of countries in the Middle East, Saudi Arabia being first, and Iran, Iraq, Kuwait, UAE, etc. And then finally, Canada. The largest natural gas reserves are found in the following countries: Russia, Iran, Qatar, the United States, and Saudi Arabia. And then potential reserves are reserves which we have a pretty good idea that exist, but they have not been definitively verified, or they're too difficult to extract. So there's a huge amount of oil, for example, that exists in something called tar sands, but it's very expensive and difficult to extract that oil out of the sand. And so in Colorado, there's a huge amount of oil that exists, but it's too difficult to get to and too difficult. And the amount of energy that it would take to extract the oil is more than the amount of oil that you would get from it. So that's why potential reserves are a little bit tricky. So resource production is different from proven reserves, right? Having something is different from actually extracting it and using it. And so it's connected to the proven reserves, but it's a different set of data, right? If you don't have coal, you can't extract it, you can't produce it. If you don't have oil, you can't produce it. But there are some countries that produce more than what they kind of have compared to other countries, and vice versa. So as we said before, China, India, and Indonesia is a new one that has just entered the market. As Indonesia has become more industrial, it's producing more coal. And the United States is declining in terms of its coal production, even though it has enough coal to last for another nearly 200 years based upon current consumption. But the United States and the UK are moving away from coal entirely. And Britain will be finished using any of its coal, even though it still has coal reserves, within the next 10 years or so. The United States will probably follow closely thereafter. In terms of oil production, the opposite is true. So the United States has not traditionally been one of the world's leading producers, but it has become a leading producer. As a matter of fact, the leading producer of oil just in around the late 2010s and early 2020s. And I'll talk about the reason for that in a second here. So the United States is the world's leading producer of oil, followed by Saudi Arabia and then Russia. But notice the absence of Venezuela. In spite of the fact that it has the largest known reserve of oil, it is not anywhere near the largest producer of oil in the 21st century. So the United States also maintains something called the Strategic Petroleum Reserve, and it's designed to be kind of like a bank account, right? A rainy day fund for in case there are geopolitical political problems that disrupt the supply of oil from foreign countries, because the United States is the largest producer of oil, but it still imports oil from different countries. The United States imports massive amounts of oil from Canada. It depends upon the geography and the needs and the ability to transport oil from one place to another, because of course oil is heavy and difficult to transport without a pipeline. So the United States most recently tapped into that strategic petroleum reserve right around the time that Russia was starting a war with Ukraine. And the reason for that was because there was fear about the global oil supply being harmed by that conflict. In recent years, and beginning in 2025, that strategic petroleum reserve has been restockpiled. And then finally, in terms of natural gas, the United States and Russia are the two leading producers of natural gas in the planet by far. So even though I've given you some of this data, I wanted to give it to you in a more digestible form. Looking at a map is always helpful. And so the world's leading producers of coal, again, are China, here we go, China, India, Indonesia, and the United States. But if you don't have coal, you can't produce it, as I said. So a lot of these places that say no data are also places that simply don't have coal reserves, or they haven't had the infrastructure to mine that coal. But in many places, it simply doesn't exist as a resource, at least not in meaningful amounts that can lead to meaningful production. And such is the case with Africa. So part of the reason that the Industrial Revolution hasn't really taken hold in Africa simply is a lack of coal, or a lack of infrastructure to mine that coal in large amounts. That has sort of been the playbook for every other country as they've industrialized, right? Again, England first, then Germany, and the United States, and then the Soviet Empire, and then most recently in Asia. It's always been coal dependent. And at the same time, not to be redundant, but the United States and the UK are diminishing their reliance upon coal and their coal. So you'll notice from this map some similarities between gas production and petroleum production, right? So the United States is the world's leader in gas production, and we also have a huge amount of known and proven reserves and also potential reserves. But the United States and Russia are the clear leaders in natural gas production, and increasingly in the late 20th, early 21st century, we're using far more natural gas because it's cheaper and cleaner than using coal to heat our homes, to produce electricity, for a lot of things. A lot of countries don't have access to coal or to natural gas, and yet it's needed, especially in more advanced economies. And so many countries of Europe have been heavily dependent upon natural gas exported from from Russia, to heat their homes and for all sorts of energy needs. And so there's a geopolitical component to this that's maybe well known to you, but maybe not. So if we look at the location of massive amounts of natural gas in northern Russia, that natural gas has been transported into places like Germany. Germany has been heavily dependent upon natural gas from Russia for a long time, as has much of the European Union, including Ukraine, which is not a part of the European Union. But the Ukraine, which I think I have an arrow, there we go, right? So the Ukraine is right here, and at the time of this recording, the Ukraine and Russia are involved in a war that's been going on for more than 2 years now. And back in 2015, the Ukraine stopped purchasing natural gas from Russia. There was a dispute over the price and also some political disagreements. And so the Ukraine now gets its natural gas from other parts of Europe and also from the United States, that's transported in by ship across the Atlantic Ocean. And so a part of the reason of the conflict between the two countries has very much to do with natural gas and with these pipelines, because as of 2025, the Ukraine also stopped allowing Russia to use the pipeline that passes through Ukrainian territory to get its natural gas into the European market. So what's happened since then? You can see the dotted lines right here, and some of these, since this map was created, have already been built. And so Russia is now in the process of selling much of its oil and natural gas to China, which has an almost insatiable demand as it's trying to move also away from coal and get access to natural gas, which it doesn't have. It's becoming increasingly reliant and forming an alliance with Russia based upon natural resource demand. So finally, as we think about natural gas one more time in the United States, it's sort of an interesting case because the amount of reserves that the United States had varied dramatically from our proven reserves to our potential reserves. And so we've known that we had huge amounts of natural gas underground around the same times, same places that we might have some oil, but we couldn't get to it, or at least we couldn't get to it easily, right, without ripping the entire environment apart. But in recent years, there have been new technological innovations, namely something called fracking, which I'll talk about on the next slide. But I wanted to start by showing you this map of where most of our natural gas comes from. So places like Texas, Louisiana, and Pennsylvania are the leading states in terms of providing natural gas. And again, on the graph, you can see the increasing importance of natural gas as the trajectory moves upward. So as we've been able to tap more natural gas resources inside of the borders of our own country, then of course the price of that gas has gone down, and natural gas is actually cheaper and cleaner than coal. So why has it become so much cheaper and more abundant in the 21st century, at least in the United States? There's one answer. It's this thing called fracking, which you may be familiar with or maybe you've heard of before. This is a significant drilling and mining technique using horizontal drilling to extract oil and gas that was not previously accessible. And so here are the steps that you can see. It's drilling first vertically, but then horizontally into the shelf where the natural gas resides. And the next thing you do is to build that well and then fill it with a fluid mixture of water, sand, and chemicals, and then you create fractures, which is why it's called fracking. And so those fractures are basically simulating an earthquake, right? You're cracking the surface of the shale and the bedrock in order to get that natural gas to start flowing out of the shelf. And so here's an image of what that looks like. This is a simplified image, of course, but this is pretty deep. This might be 1,000 meters, which is about 6/10 of a mile deep. And then from here, the drilling starts to happen horizontally. And this is geometrically kind of a hard thing to pull off, but we have some new techniques in the late 20th, early 21st century that have allowed for this. And so then once you get to where the gas is, then you fracture it and you're creating, again, these sort of simulated earthquakes. And so that's what's happening in various parts of Texas and Louisiana and in Pennsylvania. So we know we have huge amounts of natural gas in places like Michigan and Montana and in upstate New York. This provides jobs, it provides cheap sources of energy, but what are the problems? Well, there are always problems, right, with any new energy source. And so here's a list of some of them. So that when you're cracking that bedrock, you can't really predict how that cracking is going to happen, especially over time. And so once it starts, the cracking can continue beyond what the original intent was. And so when that happens, you can get water contamination, even into above ground water sources, right, that are now filled with all sorts of nasty chemicals. And so you can also have leakage in which there's water depletion. So water above ground that had been steady for a long time just sort of can disappear overnight due to the impact of fracking well below the surface of the earth. habitat destruction, and you can read the others. Also, once you start cracking this rock, it can actually increase the amount of seismic activity and lead to other earthquake and seismic activity. There's also an increase in health risks that have been demonstrated by numerous studies for people that live in and around where the fracking is taking place. So there are certain places that stand adamantly against this, and there are other places where people are very much in support of it. And here are just a few more images for you that you can sort of take in to think about the fracking problems and the environmental costs to that. So there are various places where fracking has been banned outright, nationally or locally. So France, Germany, the Netherlands, in spite of the fact that they may have access to more natural gas if they implemented this tactic, have outlawed it. Spain, the UK, but also states. So in New York, fracking is illegal, whereas in Pennsylvania, it's legal. And so Pennsylvania is benefiting economically from the access to fracking, while New York is not. On the other hand, Pennsylvania is a state that's been decimated by deindustrialization, whereas New York has a more diversified economy, and so they can afford to maybe make such a regulation, where in Pennsylvania there are all sorts of people that have been hoping that there would be a renaissance of manufacturing and industrial jobs, and fracking has provided that for them. So oil production around the planet looks something like this. Kind of talked about it already, but notice that that Africa, North Africa in particular, does have large amounts of oil, which can lead to industrialization and a kind of development of an industrial sector, a larger industrial sector in Africa, in spite of the fact that there's not much coal there. So let's move away from fossil fuels and talk about renewable sources of energy, those that are in infinite supply, that can reproduce themselves within a single lifetime. The major types of renewable energy are solar, wind, hydroelectric, biofuels, and geothermal. I mentioned geothermal when I talked about Iceland. So there's a huge emphasis on renewable energy, specifically in Europe, but many countries around the planet are focusing on renewable energy, so they don't have to constantly worry about finding new sources of non-renewable sources of energy. So 80% of new energy projects throughout Europe, especially Western Europe, but also in Eastern and especially in Northern Europe, are of a renewable type: wind, solar, hydroelectric, etc. So you can see a list of countries according to what percentage of their electricity is generated by renewable sources. And so you'll notice the geographic patterns yet again. The Nordic countries or Scandinavian countries lead the world in renewable sources of energy. So Norway, Sweden, Finland, Denmark, etc. have specifically emphasized these new sources of energy. And there's a little bit of irony here, because Norway has huge amounts of oil, and it does tap that oil and then it sells that, it exports it to other countries. Meanwhile, it's focused on renewable sources of energy for its own populations. So most people in Norway are driving an electric car. Most energy that people are using to heat their homes is generated by renewable energy, not reliant upon the oil that they produce within their own borders. China is also investing heavily in wind and solar in preparation for a future in which it doesn't want to be reliant upon oil and natural gas from other sources. So some selected country data will show you that China's electricity is generated right now by renewable sources for about 30% of its electricity generation. The United States stands at about 23%. Now, this is just electricity generation, not all forms of consumption. So most people in the United States are still driving a car that's fueled by gasoline, obviously. In China, increasingly, most people are driving cars that are fueled by electricity. But of course, that electricity is most often fueled by or generated by coal or maybe natural gas. So it gets complicated really fast. In India, even though it wants to focus on renewable sources of energy, given where its economy sits and its industrialization sits, it is not using much renewable energy yet. And then you have a country like Saudi Arabia, still almost 100% focused on fossil fuels, right? The way that Saudi Arabia has always been, it's blessed with huge amounts and overabundance of oil, which has brought great amounts of wealth. But so far, Saudi Arabia has not looked beyond fossil fuels and is still reliant on consuming its own oil in large amounts. Poorer countries, this is just sort of a random selection, but Paraguay is one of the poorest countries in all of Latin America, and yet its electricity is generated 100% from a renewable source of hydroelectricity. It's bordered by large numbers of rivers on all sides, and those rivers are dammed effectively and efficiently to provide cheap and abundant sources of electricity throughout the entire country. So people, even in the most remote rural communities, typically have access to a reliable source of cheap electricity. And then Iceland, as I mentioned before, generates 100% of its electricity from geothermal and hydroelectricity. So each country has a different situation depending upon its geography and its relative location. So as I mentioned before, the United States has a long history of reliance on renewable sources of energy, especially in the 1800s and early 1900s when hydroelectric power was the main source of energy. But the United States, like most countries around the world, is constantly looking for new sources of energy and power that are renewable and sustainable over time. So more recent developments in wind power are taking place all across the United States, especially in the Great Plains region, in places like Texas and Oklahoma, also in major parts of California, in the Midwest, in the plains of Illinois and Ohio. You see massive windmills taking place. But with every new form of energy, even when it's clean and renewable energy, there's always local resistance to that, especially if there's a possible consequence for the environment, which may be the case in certain parts of the country. The United States also has some of the largest solar farms in the world, especially in places with a large amount of abundant sunlight, places like Arizona and New Mexico, places that are pretty easy to guess. And this is true across the planet. There's also a strong emphasis on electric cars, but in the United States, this varies by state. So California has mandated a certain percentage of cars on the road be electric vehicles by a certain date. Other states across the United States haven't followed suit. Some states have given incentives to car buyers to incentivize them to buy electric cars as opposed to gas automobiles. China has focused on becoming the world's leading producer of electric cars, as I talked about in a previous chapter, and it has accomplished that. So China produces more electric cars than any country in the world, and more people are driving electric cars in China than in any other country in the world. A little bit more about renewable energy sources, and this one is something that you've encountered, whether you've thought about it or even recognized it or not. It's there. It's probably sitting in your car right now as we speak, or as you listen to me talk anyway. And we're talking about biofuels here. Biofuels are energy source that's produced from living matter, but it's living matter that's renewable, that can be grown relatively quickly within a year's time. So mostly we're talking about corn and sugarcane, but there are some other products as well. The United States, Brazil, India, and Thailand are all world leaders, and this is an update from the textbook. So India and Thailand have made major strides in improvements and expanding their biofuel capacity. So what we call it usually, and what you've probably seen before at the gas station, is ethanol production. In the United States, this ethanol is coming from American corn. The United States is very, very proficient at growing corn, and we grow corn in excess. As a matter of fact, we use most of our corn to feed animals, mostly cows and livestock. And then the second most common use of corn is that we feed our automobiles. In Brazil, they've done the same thing. They followed this pathway using a mixture of sugarcane and corn. And in India, sugarcane and rice. And in Thailand, sugarcane and cassava. So it's just a matter of chemistry and efficiency in crop production to determine which country uses what. So you've probably seen this, that the fuel may contain up to 10% of ethanol. And this is true across the entirety of the United States. It's also true in the entirety of Brazil. Brazil is especially focused on increasing the amount of ethanol that gets produced and used in its country, and the same is true in Thailand. Thailand and India, it makes a lot of sense, given that those countries don't have large proven reserves of oil and natural gas. And so it would make sense that they've looked for alternative sources. It's also a desire for these countries to become more sustainable, less dependent on imports from other countries. And so that's part of the explanation. This has a lot to do with comparative advantage. So if a country has a lot of land and has a lot of capacity to grow food and actually is growing food in excess of demand, then it would make sense to use some of that acreage of land to produce fuel. In the case of both India and Brazil, they sell something called a flex car. And a flex car allows you to use either regular fuel or ethanol, or in the case of India, only ethanol. So it's the first mass-produced car on the planet that can run entirely on biofuel. And so we'll see if that becomes a wave of the future. Another example of biofuel innovation has to do with managing waste. And so this is a digester right here in the state of Georgia that converts wastewater, taking the methane out of the wastewater, the solid waste, and finding a way to convert it to energy and to put it back into the grid for use in electricity. Okay, so there's no one size solution fits all for all of these variable sources of renewable energy, but they're being experimented with in different ways with different food sources and with different investment infrastructures across the planet. Another reason why countries are moving away from fossil fuels has to do clearly with trying to move towards a more sustainable source of energy and one that's better for the planet, especially as it pertains to global warming and the greenhouse effect, something you've probably learned since elementary school, but it's good to take a look at a graph once in a while, just in case it's not entirely clear in your mind. So there are three main gases that are contributors to the greenhouse effect, and they are carbon dioxide. And this occurs with the burning or the use and the production of coal, natural gas, burning of gasoline, etc. Methane, and the main source of methane being extracted into the atmosphere is livestock farming, landfills, fossil fuel extraction, and a few other smaller causes. And then finally, nitrous oxide, one that you probably hear a little bit less of, and this is a direct result of using synthetic fertilizer over a long period of time. So as we've mechanized agriculture and applied more synthetic fertilizer to the land, that fertilizer eventually emits, as a byproduct, nitrous oxide into the atmosphere. So what we're talking about here is the lithosphere, which is the lowest portion of the atmosphere. About 4 miles above the Earth's surface, we have naturally occurring CO2 and nitrous oxide and methane. Okay, so long before humans were ever even invented or thought of or inhabited the Earth, these gases were already in the lithosphere. Over time, the amount of greenhouse gases that exist in that layer vary considerably. So during the time of an ice age, there are fewer of these gases that happen to exist for a variety of natural processes that are going on the Earth. But what we've seen happen during the era of the Industrial Revolution and moving forward and accelerating into the 20th and now 21st century is that more of these greenhouse gases have been emitted by the actions of humans on such a scale that it's had a meaningful impact on the greenhouse, which has intensified heat on the Earth's surface. And this becomes a self-fulfilling prophecy. So even if humanity stopped emitting CO2 and methane tomorrow, there would still be a multiplier effect, because once the Earth has already warmed, it causes other things to take place. For example, the melting of ice, the melting of polar ice caps, which then triggers a new release of CO2 from long dead organisms that were trapped in that ice or near the ice to begin to decompose, which releases CO2 or in some cases methane into the lithosphere or into the greenhouse, causing this greenhouse effect. Okay, so we have a warming planet, and I think everybody is fully aware of this. And so the portion of the greenhouse effect that's caused by human activity is referred to as anthropogenic greenhouse gas production. All right, and so there is some debate about what portion of the warming of the Earth is responsible by human activity or anthropogenic causes, and what portion of it is a natural part of the Earth's cycle. But nearly 97% of all scientific communities have made statements like this one, that based upon extensive scientific evidence, it's extremely likely that human activities, especially emissions of greenhouse gases, are the dominant cause of the observed warming since the mid-20th century. There's no alternative explanation supported by convincing evidence. But as we know, science has been wrong before, so it's worth at least expressing that. But that's where we stand today in 2025. Every country in the world is taking serious steps to try to address this problem. We also have some good news. At least in the case of the United States, U.S. vehicles emit about 31% less CO2 today than they did in 2004. And that's because of more efficient fuel systems, more electric cars, better things like catalytic converters, and we have fewer cars emitting massive amounts of emissions on the road today than we did just 20 years ago. Moreover, total U.S. greenhouse emissions have declined by 17% since 2004. So I'm not saying this just to pat the United States on the back. There have been concerted efforts to try to bring these numbers down, and we have seen some success. On the other hand, we haven't met the goals that we had established for ourselves 25 years ago. And compared to other developed and wealthy countries, we're doing worse in terms of bringing our CO2 and methane and nitrous oxide emissions down. So the leading contributors of greenhouse gases are kind of obvious: energy production, agriculture, industry, and then forest and land use. The way that we've farmed and moved from small-scale farming to large-scale industrialized agriculture has had an effect on the planet. By country, the leading contributors to greenhouse gas emissions are China, the United States, and India. So the United States is decreasing its emissions, as I said. Meanwhile, India is increasing its. And China, as we talked about earlier, is building more and more coal-powered plants all the time, although its stated goal is to move away from coal and to move to more sustainable sources. They're not quite there yet. You've probably seen millions and millions of graphs like this. People in the last 30, 40 years have become made fully aware of this, especially those with higher levels of education like you, a college student. And so we've seen not just a persistent increase in global warming, but perhaps an acceleration since the 1950s, and even just in the last 15 to 20 years, an acceleration beyond what had previously been predicted. And so the change is real, and it's difficult to tell how much longer this will continue and kind of where it will end. But if you're even paying attention a little bit to the news, you've noticed in the last 10 years an increase of intensive wildfires, of deforestation, of milder temperatures in the winter, and just a changing climate. Another element that, in terms of kind of a global scale environmental issue that was human caused, is related to the ozone layer. So if we move beyond the lithosphere into the stratosphere, so about 10 to 20 miles above the Earth's surface, we start to see that there is a layer that we've called the ozone layer that tends to prevent harmful rays from entering the US's atmosphere. Those rays from the sun are the ones that are most damaging in terms of causing serious cases of skin cancer, sunburn, etc. And so scientists began to observe that there was a hole in the ozone layer above Antarctica, and that hole was allowing all sorts of increases in harmful UV rays into the Earth's atmosphere, and figured out that the cause was actually a pretty direct one from something called CFCs, or chlorofluorocarbons. If you would have used hairspray during the 1970s, or ironically sunscreen, a spray sunscreen, it was the chemical that allowed the can to spray out the ingredients. And the emission of those little tiny microsprays across long periods of time, as well as certain equipment that's used in refrigeration equipment, was actually having this really negative effect on the ozone layer. So in the 1980s, this was recognized as a problem by the international community. Scientists came together, politicians came together, and passed international regulations and one by one national regulations. And so, due to the Montreal Protocol of 1987, most of the world's countries, nearly all of them, agreed to stop using CFCs entirely. And what we've seen is that it worked. That a full recovery of the ozone layer is expected by the year 2060, and we've seen that hole in the ozone layer get smaller and smaller as a direct result of this global cooperative policy. So I know in this day and age it's tempting to think that governments can never agree across the planet on solving global scale problems, but we have evidence of cases in the past where in fact they did. So maybe there is some hope for the future. So back to some more negative news. Another example of this one isn't really global scale, but it's an issue that happens all around the planet for kind of different reasons, but a similar process, is water pollution as a result of runoff. So industrial chemicals, as a country industrializes, especially in the early years, there's all sorts of emissions of negative and dangerous chemicals that make their way into a country's water source. If you follow that water source as it moves through a river system, like in this case the Mississippi River, then we have this resulting process known as eutrophication. So this map that I'm showing you right here is the Mississippi Delta, where the Mississippi River enters into the Gulf of Mexico or the Gulf of America, whatever phrase you want to use. And when that water arrives, it carries with it kind of a legacy of all of the chemicals that have accumulated from the Ohio River and from the Missouri River and from the Illinois River and from the Arkansas River. And what we know is that there's been mass scale farming and industrialization of farming that's taken place in the American Midwest. And so as a result, massive amounts of fertilizer unintentionally makes its way from these farms and from these fields into the water source of the Mississippi River. And then as it moves further south, they accumulate into greater and greater amounts from these other tributaries. And by the time they've reached the Gulf, then they're in really large amounts. And what those fertilizers do, ironically, is that it promotes the growth of algae. And you have this thing called an algal or algal bloom, which results in massive algae growing either below the water or oftentimes above the water on the surface. The algae then steals the oxygen from that ecosystem, stealing it from fish and any other wildlife that's below the surface, and creating what we call a dead zone. And so you have things that look like this, right? Maybe really pretty from a satellite photo, but this represents massive death. As the algae dies and it starts to decompose, it also contributes to CO2 and methane emissions, believe it or not. Actually, methane, not CO2, I believe, but that one's not really that important. And so we're seeing this through the death of fish, which kills fishing industries and commercial fishing as well as sports fishing, and is just a negative impact on the environment. It's very difficult to undo once it's happened. China is experiencing the same thing for the exact same reasons. So this is some imagery from 2023, and you can see how this is just kind of gross in a tourist area that's supposed to be full of sand and clear water. Instead, it's been eutrophied, and you can see the effect on the water. It's also important to talk about the mass amount of garbage that gets produced especially in wealthy countries, but really in all countries around the world, especially now that we're sitting at well over 8 billion people. This creates a huge stress on landfill systems. So the mechanism for getting rid of trash is pretty basic. We can dig a hole in the ground and put it in the hole and try to hide it away and wait for a long period of time for some of it to decay. There's also incineration, which means large-scale burning of the trash. And the last option is recycling. The preferable option clearly is recycling, but this takes a huge amount of kind of goodwill and intentionality among people to do the recycling. So landfills is kind of obvious. We try to hide the trash and bury it as deeply as we can, but we know what landfills look like and smell like. Hopefully you've been to one before and you know what that looks like and what that smells like. In an area where there's lots and lots and lots of open space, this is usually what's been done. So in the American Midwest and the Great Plains, in more densely populated areas and areas with lower amounts of land, trash is most often burned. Oftentimes it's burned in a way that produces electricity. So this happens commonly in New York and in Florida. I think of a map here. There it is. Right? So in those areas that are most densely populated, where there isn't really space to create a new landfill, then the trash is often incinerated and then again converted into electricity. It's not the most efficient way to produce electricity, by the way, but it's better than creating new landfill space. In terms of recycling, there's a lot of variability around the world in terms of where recycling happens efficiently and effectively and where it doesn't. So you can see from the list on the right side of the screen that there are certain countries that do really, really well, where more than 45 or 50% of the materials that are consumed get recycled in one way or another. So if you've traveled to a country that takes this seriously, you know it, you feel it, you're shamed. There are places in around the world where you can't go to a grocery store and ask for a plastic bag. They won't give it to you. They don't exist. They've been outlawed. Even a country like Chile has done that to avoid the waste that plastic bags cause. And there are a million other examples of that. But Germany, Slovenia, South Korea are all leaders in this. But by far, the country that recycles the most is Austria, followed by Wales, Taiwan, and Germany. So what do these places have in common? They tend to be wealthy. They tend to be small. They tend to be densely populated. And there's one more item. I don't know if you can guess it. But there are lots of small, wealthy countries that aren't showing up on this list. They tend to be culturally connected to collective action. So it's not an accident that places like the Netherlands and Denmark, South Korea, Austria, and Wales are participating in these kinds of activities, because there culturally tends to be a commitment to the greater good that doesn't always exist in other countries in the world. Another way that natural resources are preserved is not through recycling, but preserving them in the first place. So protecting areas and not allowing humans to cut down forests or to consume resources that are there, or to hunt or to fish. And another way that we can do this is through conservation. So you should know the difference between conservation and preservation. Preservation is protecting a natural area from human encroachment. Conservation involves replanting of trees or trying to repair an environment to its natural state after maybe deforestation happened, and limiting the amount of use that can take place there. National parks are an excellent example of preservation efforts and have only been around for about 125 years. The United States is a world leader in the national park system. We have more national parks than any other country in the world, with more area devoted to national parks. And a lot of countries have followed suit. So this is an example of a national park in eastern India that is preserving a natural landscape, but also serving to protect the endangered species of the Bengal tiger, of which there are only about 4,500 remaining. So here's a map of national parks in the United States, and you probably notice, or maybe you already know, the geographic pattern that exists here. And so the majority of all national parks and national park space are in the western states. It's only been recently that some areas in the eastern part of the United States have been converted into national parks. Moreover, apart from national parks, the federal government actually owns nearly half of all the land in the 11 contiguous western states. So you can see the list here: Nevada, Alaska, Utah, Idaho. The federal government owns far more land than is owned by municipalities or by private owners. So the last area of preservation that's worth mentioning here, not just on land, but also in maritime preserves, has increasingly proven itself to be an effective mechanism for protecting fish and wildlife in the open seas and in ocean, or even in parts of the ocean that are in the jurisdiction of one or more countries. So what we do know is that about 75% of the world's fisheries are fully exploited, overexploited, or even depleted. We saw that with the cod fisheries in North America in the 1990s. So one of the most practical solutions to this problem has been the establishment of large amounts of preserved land. You can think of these as sort of national parks that take place in the ocean. And there's a long list. If you're interested in any of these, you can find this on the internet for yourself. So these are known as marine protected areas, and oftentimes countries work collaboratively together to enforce the protection and to keep fishermen from fishing here, or from trash or any other sort of encroachment into those spaces. And what that does is it allows fish species to regenerate, even when they've been overfished very nearby. So to conclude, I think this is kind of obvious, but the Earth's ability to sustain human life remains very fragile. So far, human progress has managed to sort of stave off starvation on a massive scale, and our carrying capacity has continued to grow. As we talked about in the population chapter, many experts in the 19th and early 20th century believed that humanity was doomed, that there's no way we could produce enough food, and that we were destroying the planet at such a rate that there's no way that human livelihoods could be sustained into the 21st century. So it remains an unanswered question as we move into the future. But consider this: the Earth's age is approximately 4.6 billion years. The dinosaurs lasted about 165 million years. Homo genus has been around for about 2.5 million years, and Homo sapiens only around 300,000 years so far, right? So we are just a blip on the map of human history, and yet humanity has ushered in what many are agreeing is this new era of the Earth, and it's been termed the Anthropocene. This is sort of a controversial term, but the impact that our 8 billion plus people have had on the planet is at such a stage that we've created rapid declines in biodiversity across the planet by manipulating agriculture on every corner of the Earth. Mass-scale human-driven biological, biochemical, and geological shifts on a global scale have had perhaps irreversible effects on the Earth's natural systems. We've also experienced a proliferation of human-made materials and pollutants, mostly things like chemicals and plastics that didn't naturally exist in Earth's system before. We've also seen massive species migration. And so the notion of invasive species is almost laughable in the 21st century, because almost every species or almost every ecosystem has a variety of invasive species. Just think about Burmese pythons in Florida, for example. And finally, the future of humanity is really impossible to predict, but careful attention to Earth's natural systems is essential for survival, for thriving, and securing a positive and sustainable trajectory for future generations. And with that, we will end this chapter. Thank you.